Hi, welcome to another video. I'm going to see if I can do a video on servos in less than 5 minutes. Now you can set up timer interrupts and drive the servo with a specific signal, but adjusting it on the fly in an interrupt is quite difficult. Easy to use PWM, so that's what I'm doing here today. Now for those of you who don't know about servos, I'll give you a look at the scope. This is my PWM, so pulse width modulation, so I'm modulating or adjusting the width of this pulse. And on a servo they happen every 50 Hertz or 20 milliseconds. There's the start of the first pulse, there's the end of the first pulse, 50.5 Hertz, just under 20 milliseconds. Most servos want a pulse width of 1 millisecond to 2 milliseconds. 1.5 will be the middle of the travel. So 1 millisecond will be at one end of the range, 2 milliseconds will throw the servo to the other end of the range. I'll demonstrate on this servo, it's not the case. So I'll adjust this potentiometer, 1 millisecond, hopefully you can hear the servo moving. If I go up to 2 milliseconds, 2 milliseconds, that's 2, and the servo's near one end of its travel, down to 1. So you can see the period wasn't adjusting, just the width of the pulse, from 1 millisecond to 2 milliseconds. Now listen to this servo beneath 1 millisecond. So listen to the servo. The servo's actually hitting the camera base. So you can see this servo is working down to a pulse width of, what's it, 450 odd microseconds, up to 2.5 milliseconds. There's one end, other end. So now you've seen the pulse width and how it works, how the servo works. It's stuck to the desk here with blue tack. I weighed this reel of solder earlier, it weighs just under 400 grams. I'm going to push this 400 grams along this surface, so that's additional friction, with this servo and an extended arm. I think this is actually a 17 kilo servo, 17 kilos at 1 centimetre. But the sticker's come off, so don't know. Right, here's the wiring diagram. I'm using a Pic Micro-controller, the 16F886, running on the internal oscillator 500 kilohertz. Pulse width modulation 1, because this chip's got 2. PWM 1 is on RC2, and I'm using the ADC on RA0, which is ADC 0. The servo's wired to 5 volts ground and the PWM orange wire running to RC2. The potentiometer, instead of wiring it to 5 volts, I've got it wired to a 3 volt regulator, because when the servo starts running, the motor draws a current, the voltage sags, and then the voltage here would sag. Hopefully you can see my mouse moving. So to stop that happening, I'm running a 10k potentiometer off a 3 volt regulator. That should be, the regulator should have some sort of smoothing capacitor after it, stop it oscillating. And then to stop jitter, I've got a 1 microfarad capacitor between the ADC input and ground. And just turn the potentiometer and it turns the servo. So I'm using Microelectronica's Micro C Pro for Pic. Initializing the PWM 1 at 51 kilohertz. That just makes up for a slow clock. So 50 hertz initialization, Duty cycle I'm setting initially at 10%. PWM1 start, initializing the ADC, read potentiometer equals ADC get sample from the AN0, so analog 0 channel, and then the value of that potentiometer multiplied by 0.052 times the value it read will give you a duty cycle you can put here. So PWM is set duty cycle, read potentiometer, and a 10 millisecond delay. And that's it. So hopefully that's given you an insight into servos and how to control them with a Pic microcontroller. Thanks for watching.